Questions 3, 4, 5, 6, we're doing every second one, so the first and third columns. For this one, you're just putting it back into index form. I'd like to remind you, if I have log a to the b equals c, then that means a to the power of c comes out as b. So we're trying to figure out what power we raise the base to get the answer. So I'm going to highlight these. So the base is this one. And then the answer after you've raised it to whatever is this one, and trying to figure out what we're raising it to is this one. And if it helps you, you can start by highlighting them every time. I think when I was learning this, I didn't highlight it, but I definitely always wrote it out, like deliberately. I would write this thing out every time and then figure out what everything was. So if we've got x equals log base 10 to 1,000, that means 10 to the x equals 10,000. And we want to solve it. So 10 to the what equals 10,000? Well, 10,000 is 1, 2, 3, 4, 0, so it's 10 to the 4, which means x equals 4. All right, if we do question C, bit easier this one. We've got x equals log base 10 of 100, which means 10 to the x equals 100. You should know this straight away without having to write the next step. So x equals 2. And if I was going to skip a step of writing out, I would skip this one. I wouldn't skip the others. A, C, E, we've got log base 10 of the 1. So 10 to the x equals 1. Now, having a 1 here is a bit of a gimme, because there's only one way to end up with anything to the anything equals 1, and that's for it to be 0. So 1 is the same as 10 to the 0. So x equals 0. So every time you've got 1 here, this is your answer. F, G. So we've got, well, this one's a bit harder. We've got x equals log base 10 of 1 on 100. So we've got 10 to the x equals 1 on 100. Now this is 10 to the x equals, well, 100 is 10 squared, isn't it? And if I want that not as a fraction, that would be 10 to the minus 2, wouldn't it? So x equals negative 2. Hopefully you're almost at a point where you can go from that and see those straight away, because it's very useful to be able to do that in your head. Okay, these ones, so the ones we did all above were all base 10. Base 10 is nice, we know it, we just have to count the zeros. These ones you're going to have to actually think. So we've got x equals log base 3 to 9. So 3 to the x equals 9. Log base 3 of 9, that's how you say it. Okay, which means we need to get them both as the same base. Well, the 3, that's already as simple as I can do it, so 9 is 3 squared, so x equals 2. C, what do we have? Log base 7 of 49. You should know this straight away. So that means we've got 7 to the x equals 49. So you probably don't need to write 49 is 7 squared. Like, you can go straight to that line. Log base 4 of 64. I don't need to write that, that's the question. Why am I writing the question? So I've got 4 to the x equals 64. 4 to the x, well, 64 is 4. If you ever wonder about this, by the way, you can just get your calculator out. So we've got 64. And we're going to divide it by 4 repeatedly. So we've divided it by 4 once, twice, 3 times, and we end up with 1, so it's to the 3. So you just keep dividing it by 4 until you get to, by the base, until you get to 1. And it's how many times you divided it is the power. So x equals 3. G, we've got x equals log base 8 of 8. Now this is a really good one to know. This means 8 to the x equals 8. Well, that's to the 1, isn't it? So x equals 1. So every time you end up with log base whatever and it's the same, the answer is going to be 1. Every time. I. So we've got log base 7 of 1 on 7. So we've got 7 to the x equals 1 on 7. Now this is the same as 7 to the minus 1. So x equals minus 1. Ijk. We've got 11 to the x equals 1 on 121. Now I know 121 is 11 squared, isn't it? So that's 11 to the x equals 1 on 11 squared. I don't want it to be a fraction, so that's 11 to the x equals 11 to the minus 2, so x equals minus 2. You don't have to write all those lines of working out. If you already know it, don't bother. So we've got 4 to the x equals 1 on 64, so that's 4 to the x equals 1 on 4 cubed. So 4 to the x equals 4 to the minus 3, x equals minus 3. Last but not least, O. So we've got 2 to the x equals 1 on 64. By the way, I always write this first line out, always, always, always. Which means 2 to the x equals 1 on, that's 2 to the 6. So 2 to the x equals 2 to the minus 6. You probably didn't need to write that. X equals minus 6. All right, now we're doing... Okay, so this one's slightly different. We're still going to write it out properly, but this time it's 7 to the 2 equals x. So whether it's ever this one to this one equals this one, if that makes sense. So 49 is x. So this one's much easier than just previously. So this time we've got 5 to the 3 equals x. So 125 equals x. Question E, we've got log base 4 of x equals 3. So 4 to the 3 equals x. Well, that's 64. It's really good to know some of these off the top of your head. F, G. We wrote up a list at the start of 7a/8a. It's good to know that. So we've got 10 to the 3 equals x. So 1,000 equals x. HI. This one's cool. We've got 13 to the minus 1 equals x. So this time it's a 1 on 13 is x. JK. So now we've got 10 to the minus 2 equals x. So 1 on 100. LM. So we've got 5 to the minus 3 equals x. So 1 on 125. NO. Here we've got 2 to the minus 5 equals x, so 1 on 32. P, oh, that was the last one. All right, let's have a look at question 6. Next page. Rewrite each in index form and solve it for x. Remember that a base must be positive and not equal to 1. So that's a really important thing with these. The number down here, it's not going to be 1, because you can't do 1 to the anything and have it equal anything other than 1. And we also can't do negatives. We're going to talk about that much more later. Let's have a look at I. So here we have, so it's the thing at the bottom to the other side equals 49. So x squared equals 49, which means x equals the square root of 49, so x equals 7. We don't include x equals minus 7 because there's a whole definition of logs that I'm going to get into next time. You can't have negatives. So here we've got x to the 3 equals 27. So x equals the cubed root of 27. If you don't know these, you can put them in your calculator. So x equals, which is the same as 27 to the 1/3, which you practiced last time. And this one was the same as 49 to the 1/2. X equals 3. Now we've got x squared equals 10,000. So x equals the square root of 10,000. So x is 100. FG. So here x squared equals 64. So when I go these, it's always the same as, you might actually want to write this at the top of every page to remember what goes where when you do a problem. It's a very good one. So x is the square root of 64, so x equals positive 8. HI. So we've got x to the 1 equals 11. Well, the only thing that's raised to the 1 that gives 11 is 11. Because it's the 1th root of 11, so it's 11. So if you ever have 1 here, this will be the same as this. JK. Okay, we've got x to the minus 1 equals 1 on 6. Well, that's the same as x to the minus 1 equals 6 to the minus 1. So what do you reckon x is? 6. LM. Here we've got x to the minus 2 equals 1 on 9. So 1 on 9 is the same as 1 on 3 squared. So we've got x to the minus 2 equals 3 to the minus 2, so x equals 3. M and O. Last but not least, we've got x to the minus 3 equals 1 on 8. So this is x to the minus 3 is 1 on 2 cubed. So x to the minus 3 equals 2 to the minus 3, so x equals 2.